On the 22nd of September 2024, a patch of empty-looking sky suddenly flared with light so intense it briefly outshone every single star in its entire host galaxy, combined. Billions of stars, and for a few days, this one point of light burned brighter than all of them. Then, within roughly a week, it faded almost completely, as if it had never happened at all. Astronomers call this class of event an LFBOT, a luminous fast blue optical transient, and honestly, the title of this video undersells what actually happened. 1,000 times brighter than our sun barely scratches the surface. This explosion, nicknamed the Whippet, radiated more energy in its first 45 days than an entire ordinary supernova produces across its whole visible lifetime, over 100 times more, from something that appeared and vanished in the blink of a cosmic eye. This wasn't the first event of its kind. The first one ever spotted, back in 2018, earned the nickname the Cow, simply from its randomly generated catalog name, AT2018 Cow, and it immediately confused everyone who studied it. It rose to peak brightness in days rather than weeks. It glowed intensely blue, hotter than a typical exploding star should. And then it was gone, almost as quickly as it arrived. Over the following years, astronomers found roughly a dozen more events like it, rare enough that piecing together what caused them took nearly a decade. Two competing explanations dominated the debate. Either these were some strange, previously unknown category of supernova, a star dying in an unusually fast and violent way, or they were something else entirely, matter falling into a black hole and being consumed in a sudden, catastrophic burst. For years, neither explanation fully matched the data, and the mystery simply sat there, unresolved, one of astronomy's most stubborn open questions. Then came the Whippet, and its sheer brightness finally gave researchers enough signal to work with. A team led by researchers at UC Berkeley calculated the total energy released, and the number ruled out an ordinary stellar explosion immediately. It was roughly 100 times too much. But the real clue came from watching how the brightness faded over time. The decline followed a very specific mathematical pattern, one that doesn't come from a star simply blowing itself apart, but from matter spiraling into a black hole and being consumed in stages, the signature decay curve of what astronomers call a tidal disruption event. In December 2025, the team published their conclusion. These explosions are caused by an intermediate mass black hole, somewhere between 50 and 100 times the mass of our sun, violently shredding a massive companion star within a matter of days, the star's own material heating to extreme temperatures as it's torn apart and swallowed. One researcher on the project put it simply: this was the first time these transients were confirmed to require a central energy source beyond anything a supernova alone could produce. Here's why that finding matters far beyond solving one mystery. Astrophysicists have theorized for decades that intermediate mass black holes should exist, a missing link between the black holes formed from dying stars and the supermassive giants sitting at galactic centers. But direct evidence for them has been extraordinarily hard to find. The Whippet may represent the clearest confirmed detection of one of these elusive objects ever recorded, caught in the exact act of destroying a star. But even with the central mechanism finally identified, new questions kept appearing almost immediately. In January 2026, follow-up observations using radio telescopes detected an unusual, unexpected trace of gas surrounding the explosion, material that didn't fit cleanly into the picture scientists had just pieced together. And by April 2026, a broader survey of where these events tend to occur revealed something else strange. LFBOTs keep showing up in the sparse, dim outskirts of galaxies actively forming new stars, unusual locations that don't fully match where astronomers expected to find the right conditions for this kind of black hole and companion star pairing in the first place. So the central question, what actually causes these blinding flashes, finally has a real answer, one confirmed through years of painstaking multi-wavelength observation. But the environment they occur in, the exact populations of stars and black holes producing them, and how common they really are throughout the universe, all remain active, unresolved threads. That last question may not stay unresolved for long. With only around a dozen of these events confirmed so far, astronomers expect the newly operational Vera Rubin Observatory to detect potentially hundreds of them every single year, transforming a rare cosmic curiosity into an entire new field of study almost overnight. What do you think? How many of these black holes have already destroyed a star somewhere out there, flaring brilliantly for a few days, completely unnoticed because nobody happened to be looking? Let me know in the comments. Subscribe, because next time we are covering quark stars, a theoretical object even denser and stranger than a neutron star, made of matter crushed so violently that neutrons themselves are believed to break apart entirely.